Welcome to Unit 5, Lesson 4, Problem Solving with Linear Systems. So here we're going to apply what we've learned about our linear systems and how to solve them into some actual problems that we might see or you could see in a real-world scenario. Because like everything we do, we try to relate it to something that you might see or you might use. So we have three choices to solve all these problems. We have the graphing method, the substitution method, or the elimination method. It is your choice which one you use to solve. Some of them may be easier one way or the other, but it is always your choice which one you want to do to solve. And I would also look to see how we set up our equations to see, because one equation might be easier to do one choice than another. So let's begin. So the first example here we have find the value of two numbers if their sum is 12 and their difference, I forgot to spell difference all the way, difference is 4. So we're going to find the value of two numbers if their sum is 12 and their difference is 4. Now this is just kind of like a warm-up. So we have two numbers. Let's say x equals a number, y equals a number. So we know that their sum is 12. Well, sum means addition, so we can say that x plus y equals 12. And their difference is 4. So that means if we do x minus y, we're going to get 4. Okay, now we've taken that word problem and we've turned it into a linear system that we've been working with and that we know how to solve. And the way it's set up, it looks like it's set up best for elimination. So what I want you to do now in your group is go ahead and solve this using elimination. So pause the video and do that now. Alright, so it's already set up, so we're going to add them. So we get x plus x is 2x, our y's are going to cancel, and then we get 16. So we divide by 2, and we see that x equals 8. So we're going to pick one of our originals. Let's just pick the first one. We get that 8 plus y equals 12, so y equals 4. So, now this isn't just x and y equals what they equal. We're answering a question. The problem's solved and we have to think, what two numbers can we add together and get 12 and then have a difference of 4? Well, those two numbers are 8 and 4. Okay, so here's another problem similar to that. I want you to, in your group, pause this video and work through the problem now, please. And after you create your equation and solve it, you see that the two numbers that make this statement true, these statements true, is the number 8 and the number 5. So 8 and 5 are solutions to the question. Other times you'll see questions like this, where you have a scenario. So here we have a store that sold 28 pairs of tennis shoes for a total of $2,220. They have one style, style A, that sold for $70 a pair, and style B that sold for $90 a pair. So we want to know how many styles were sold. And it should be how many of each style were sold. So let me throw that in there. Each style. Sorry, my English is bad. So how many of each style were sold? Well, again, we're going to have to create two equations. Whenever you're dealing with a problem like this, the best advice that I can give you is to look at and separate your ideas, your items. What do you have? What are we talking about? Well, we're talking about pairs of shoes, and then we're talking about money. So we have pairs of shoes and money. So let's let x equal the number of style A, and let y equal the number of style B. And then we have our two ideas, shoes and money. We need to make a shoe equation and a money equation. So, start with the shoe equation. We know that we sold 28 pairs of tennis shoes. And that's really all we know about the shoes. Now we have to think about, okay, is there anything that's going to affect the number of each style? When you think about it, there's no. It doesn't say that for each pair of A that was sold, we sold 2 of B. It just says we sold A and B. So we can assume that the equation for that is just x plus y equals 28. We sold so many of x, we sold so many of y, and we got 28. So the next one needs to be money. Now we know the total amount of money that we made was $2,220. Now we need to look and see if there are any stipulations with the styles. Well, we know that style A sold for $70 a pair. So that means it's going to be 70x. We know that style B sold for 90 a pair. So we know that's going to be a plus 90y. So now we have our two equations. And looking at this, I probably don't want to do elimination, because that means I'm going to have to multiply this by a negative 70 or multiply it by a negative 90. And that's just a lot to do. I could graph it, but that means I'd have to mess with graphing this, and that's going to be difficult. So my best bet's probably to do elimination. So I'm not elimination, I'm sorry, to do substitution. So I'm going to change this formula, this equation. I'm going to have it be x equals, so I'm going to say that x equals 28 minus y. Then I'm going to substitute that in here. So I know that 70 times 28 minus y plus 90y equals 2,220, and then we solve. 70 times 28 is 1,960 minus 70y plus 90y equals our 2,220. If I combine my negative 70y and my 90y, I get a plus 20y. Then I'm going to subtract this 1960. Oops. And we get that 20y. If we come up here, we get 20y equals 260. Sorry, just punch it in a calculator. Make sure that I get it right. Divide by 20. And we see that we get 13. So we know that we sold 13 pairs of style B. So I'm going to put that up here. What we're going to do now is I'm going to erase some of this, and we're going to plug that into this. So we know that x equals 28 minus y, so x equals 28 minus 13, so x equals 15. And y equals 13. So we sold 15 pairs of style A and 13 pairs of style B. So yes, these problems are a lot more involved and they require a lot more thinking about what's going on in order to create our equations that we're going to solve. So here is a problem that I want you to try in your group, so go ahead, pause the video and try this now. Alright, here is the two equations that I came up with. I let x equal number of senior tickets, y equal number of child tickets. We get 30x plus 10y equals 380. That explains the first night. And then we get 30x plus 20y equals 520. That explains the second night. Here was a little bit different than before to create our two equations because we had to think about, yes, there's senior tickets and child tickets and money, but the tickets are very similar as an idea of what they are, but we have these two separate nights that we had to come into effect. So this, we had to make a first night equation and a second night equation. So I want you to go ahead and solve this system if you haven't already, and then I will give you the answer because I don't have enough space to do all the work. And we find out that the child tickets are $8 each, and the senior tickets are $8 each, and the child tickets are $14 each.